Hello viewers, Mr. Nyati, your presenter here with another video which is basically a continuation of the 2023 GCE past paper in section B. We continue and we move on to question B3, but may I suggest that you like this video, subscribe to this channel, and also share your comments in the comment section. We move on to question B3. The question reads as follows. Figure B3.1 shows the direction of four forces acting on a car whose weight is 8,000 newtons. So in the back of your mind, you need to know that the mass is dividing this 8,000 by 10, which would give us 800 kgs. Knowing that the formula for weight is weight equal to mass times force of gravity or acceleration due to gravity or the gravitational strength. And so it travels in a horizontal straight line. So if you look at this car, there is this force acting in this direction and this force acting in this direction. Okay? Now, let's find out what the question is saying. Which two forces should be equal to the car to move, should be equal for the car to move at a constant or at constant velocity? Well, what you need to understand is that in this case, for the car to move at constant velocity, these two forces that are acting in opposite direction must be equal. Okay? In this case, forces B and D should be equal for the car to move at constant velocity. So the answer there would be forces B and D. Okay, so this would be the answer, forces B and D, and both of them, this would result to 1 mark. We move on to the next question. The next question reads, the following table, which is table B3.1, shows sizes of forces acting on the same car after it had covered a certain distance. Take G as 10 Newton per kg. That is gravitational strength or field strength, or that is the force of gravity acting on the mass of an object. So we have force A, we have 800 Newton, force B, 1000 Newton, force C, 8000 Newton, force D, 600 Newton. So calculate the mass of the car. Remember I said that in the back of your mind you need to understand that the mass of the car is basically 800. And how do we arrive at that 800? Well, B1, when we write the data, okay, we know that the weight of the car is 8,000 newtons. G, we are told that it is equal to 10 Newton per kg. And then the mass is what we do not know, and we are supposed to calculate that. Well, from the formula, we know that weight is equal to mass times force of gravity. And then what we want here is mass. So we make mass the subject of the formula, and then we are going to have mass being equal to weight over force of gravity. And what is our weight? Our weight is 8,000 newtons divided by 10 Newton per kg. This goes, this goes, this goes, this goes, and we are going to have our mass being equal to 800 kg. This being the answer. Okay, we move forward. The next question says, okay, so the resultant force, okay, this question, the way it is, okay, we are going to consider the way the cars are in this case. Okay, so we will consider this and get the resultant force from this. Why? Because in the question we were told that this car is moving horizontally, and so if we want to calculate the resultant force, we should base our calculations on the way the question is structured, and it is telling us to say it is horizontally traveling in a straight line. And so the resultant force basically would be this versus this. Okay, so the question seems to be somehow incomplete because we have also forces acting up, okay, in the sense that we have this force, we have this force, okay, these two and these two. So when we say resultant force, which ones are you specifically looking for? And what you have allocated here is a 1 mark. Okay, so that's why I'm saying this question seems to be somehow incomplete, but we move on with what is there for us. So the resultant force in this case, we're going to look for, this is 1, and so this is 2, resultant force on the car. We're going to say resultant force is going to be the product, no, not the product, but the two forces, these two, force B and D, you are going to basically subtract these two, okay? The smaller one being subtracted from the bigger one. So the difference between the two is what the resultant force is. So in this case, we're going to say which one is bigger, force B. So we're going to say force B minus force D. And we're going to have force B, which is 1000 newtons minus 600 newtons. When you subtract, the difference remains to be 400 newtons as resultant force. Okay, but again, the reason why I was feeling that this question is incomplete and the number of marks that are allocated there are somehow not all that enough, because we are considering the whole force. The force, even these forces must be considered. Okay, so this therefore means that for these two forces, the car would be dragged in this direction by a force of a net force of 400 newtons. Okay, but what about these two forces? We need to include them in calculating the resultant force. So we have just found the first part of calculating the resultant force. The other one, we should also consider these two. Okay, we should also consider the resultant force, which is between force A and force C. So in this case, force A is 800, force C is 8000. So we're going to say force C minus force A. Force C is 8000 newtons minus 800 newtons. When you do the math there, you are going to find that it will be 7200 newtons as another resultant force. Now, we need to find the overall resultant force. We've just found two forces being the resultant force, okay, or resultant forces, but we need to find this. So now, this is where we need to somehow consider using something related to vectors in mathematics. What am I saying? So it's like we have this force pulling the car this way of 400, not 600, but 400 newtons, okay? And then there is another force, okay, which is, remember, force C is bigger than force A, which is pulling like this, and this force is, let me just rewrite this. Okay, we are trying to resolve here. So we have a force of 400 newtons pulling this way and another force of 7,200 newton pulling this way. So now, in this case, if you've done advanced physics, you realize that for you to find the resultant force basically, it will be like this one here, okay? Okay, so now, this is going to be, this is 7,200, this is 400, and these two, for you to resolve these two vectors, you need to use the Pythagoras theorem, basically, which is going to say that, you're going to say that the resultant force of these, the differences here, which we have found from 8,000 minus 800 and also 1,000 minus 600, would be this. We're going to use this, the bigger one, remember the Pythagoras theorem, basically, will tell us that we could have had actually to say hypotenuse squared is equal to adjacent squared plus opposite squared. So to remove this, we are going to say hypotenuse is equal to adjacent squared plus opposite squared. So this is what we've just picked and brought it here. So we're going to say 7,200 squared plus 400 squared. And what would be our answer there? We're going to say, press on 7200 squared. This would give us this number, okay, which will be 551,840,000 plus, and we say 400 squared would give us 160,000. Okay, these, when we add them, plus this one plus 51,840,000 would give us 52 million, and the square root of this would be 7 to 11. Okay, 7 to 11.10. So 7 to 11.10 Newton being the resultant. Sorry, it wasn't visible when I was solving this. This one being the resultant force. So a continuation from, that's why I was saying this question sounds to be very, very incomplete. That is depicting it from the mark allocations point of view. When you say resultant force on the car, it means that you have to find this, and then you end up resolving those two in a vector way, and you come up with this as the final answer. But because of the way the question is, one would end here, and I'm sure you'll still be given a mark for that, because the question basically demands for 1 mark, and you can't give 1 mark for one who is going to solve all this. Okay, yeah. So we move on to the next question. The next question says, calculate the acceleration of the car. So now we're going to calculate the acceleration of the car. So for us to calculate the acceleration of the car, we need to make sure that we have the data. Okay, what data can we generate from there? Well, we can generate the force that we have from there. What else can we find from there? The mass and also the acceleration. So the question is, what is the force? So because of the nature of the question, we're going to stick to this part. We're not going to go all the way calculating these that I did calculate in the first place. We're just going to end here. Okay, so this one being the resultant force acting on the car. Remember, the car which is moving horizontally. So this is the resultant force that we calculated. Okay, So now, when we are to do the data, we have the force. Which force are we going to pick? The resultant force, which is 400 newtons. What is the mass of the car? Well, the mass of the car is basically 800 kg. Okay. What is the acceleration? We don't know, but we know that there is a formula which is saying that force is equal to mass times acceleration. Now we want acceleration, so we're going to divide both sides by mass, so that we have our acceleration being equal to force divided by mass. Okay, so now what is the force? Our force is going to be 400 newtons over our mass, which is 800 kgs. And what is the answer there? Okay, so we're going to say 8 into 4, it is 0 point, we add a 0, 8 into 40 is 5. What are the units for acceleration? Meters per second squared. This is the what? This is the acceleration of the car. So remember, I had said that the question sounded to be incomplete, and we ended up going this route to find, that is for question question B3, B2, resultant force. We ended up going this route and then resolving. But the whole idea is that the way the question was phrased, because we have 4 forces acting on the same car, so for us to find the resultant force, we should have gone this way. But when you look at the mark allocation, at your level, 5124 stroke 1, which is physics, at your level, you end here. This is very correct, okay? When they say resultant force, you pick the forces, these 2 forces that are acting on the car, which is moving horizontally, okay, in a straight line. So these 2 forces, you find the difference, then that is the resultant force. Okay, and then that force is the one you are going to use on determining the acceleration of the car. Okay, and its mass. I hope this video was helpful. So the correct answers here would be these being the mass. First, starting from here, the correct answers would be, the first question says which 2 forces should be equal for the car to move at constant velocity? We have these 2 forces, force B and force D. And because of that, we are going to do the resultant force calculation from these 2 forces. Okay, so this one being the answer, we move forward. This question says, calculate the mass of the car. We're going to use this way. We find the data, then we make M the subject of the formula. We divide 8,000 by 10, which is giving us 800 kg as the mass of the car. Resultant force, we're going to make sure that we use the 2 forces, those forces which were supposed to be equal according to the way the question wanted it, for the car to move at constant velocity, which is force B and force D. We calculate from there. The difference gives us the resultant force, which is this one. Then we go to the next question, which says what is the acceleration of the car, and then we use the formula force is equal to mass times acceleration, but we make acceleration the subject of the formula, force over mass, and then we do the math. What we're going to find is 0.5 meter per second squared. I hope this video was helpful. Thank you. Bye-bye.